On the 12th of August, the moon will pass in front of the sun. Along a narrow strip of the planet, the sky will go dark and stars will come out. It is the first total solar eclipse over mainland Europe since 1999. Everywhere else in Europe sees a partial eclipse. In Germany, up to 90% of the sun will disappear. 90% sounds like almost the whole thing. It is not even close. Start with why an eclipse looks the way it does at all. The sun is about 400 times wider than the moon. It is also about 400 times further away. Those two numbers cancel out. From here on Earth, the sun and the moon appear almost exactly the same size in the sky. There is no physical reason for that. Nothing links the size of the moon to the distance of the sun. It is a coincidence, and we happen to be alive during it. That coincidence is what makes totality possible. The moon covers the sun's blazing surface almost perfectly, but not the faint atmosphere around it. If the moon were slightly smaller, it would never quite fit. If it were much larger, it would blot out the atmosphere as well, and there would be nothing to see. So why doesn't this happen every month? The moon passes between us and the sun every 29.5 days. The reason is tilt. The moon's orbit is tipped about 5 degrees relative to Earth's orbit around the sun. Most months, the moon's shadow passes above us, or below us, and misses the planet entirely. Only when the alignment is nearly perfect does the shadow actually land. And when it lands, it is small. The dark inner shadow, the umbra, is typically only around 150 kilometers wide, while the path it traces is thousands of kilometers long. This time it runs from northern Siberia, across Greenland over the west coast of Iceland, down through the Atlantic, and across northern Spain. At most, totality lasts 2 minutes and 18 seconds. Everyone outside that strip gets a partial eclipse, and this is where nearly everyone is misled. Across Germany, between 84 and 92% of the sun will be covered. That sounds like you are seeing almost the same event. You are not seeing the same event at all. The problem is that brightness does not work the way we assume. Our eyes compress an enormous range of light into what feels like a gentle scale. Step outdoors on a bright day, then walk into a room and it feels a little dimmer. In raw numbers, it can be 100 times darker. The eye simply hides the difference. Now take an eclipse at 90%. 1/10 of the sun's surface is still visible. That remaining sliver is still overwhelmingly bright. It is thousands of times brighter than the sun's outer atmosphere, which means the corona, the thing people travel across the world to see, stays completely invisible. Even at 99%, it is invisible. It only appears when the last sliver goes. And then, in a couple of seconds, the sky changes completely. The sun's outer atmosphere becomes visible around a black disk, streaming outward, 1,000,000 degrees hot and fainter than the full moon. Bright stars and planets appear. The temperature drops. Birds go quiet. Along the horizon, in every direction, there is a band of orange light because you are standing inside a shadow only 150 kilometers wide, and outside it, it is still daytime. None of that happens at 90%. At 90%, the light goes strange and slightly metallic, shadows sharpen, and the temperature dips. It is genuinely worth watching, but it is a different category of event, and the difference is not 10%. It is closer to the difference between dusk and midnight. Which brings us to the part that matters most. During every partial phase and everywhere in Germany that means the entire eclipse from start to finish, you must never look at the sun without certified protection. Not with sunglasses, not with smoked glass, not through a camera, binoculars, or a telescope, even wearing eclipse glasses. Look for the standard, ISO 12312-2. The retina has no pain receptors. damage happens silently, and it can be permanent. In Germany, the eclipse begins around 7:15 in the evening and reaches its maximum shortly after 8, low in the west-northwest, close to sunset. You will need a clear horizon in that direction, so a hill, a field, or a coastline. Along the path itself, in Iceland and northern Spain, totality arrives in the late afternoon and evening. And there is one last thing. The moon is drifting away from Earth by roughly 3.8 centimeters every year. It is slowly shrinking in our sky. In several 100 million years, it will be too small to cover the sun, and total eclipses will simply stop happening. Forever. The coincidence that makes all of this possible has an expiry date. It just happens to fall a very long way after ours.